Hello everyone. So this is the second lecture on cycloconverter. So in the first lecture I have explained introduction about cycloconverter. Now in this lecture I will start different types of cycloconverter. So I'll start from step up cycloconverter. So basically step up cycloconverter is classified in two types. One is bridge type, another one is the midpoint type. So in the bridge type, basically there are two converters are there. One is positive converter, another one is the negative converter, and each converter have four semiconductor switches. So total 8 switches is there in the bridge type cycloconverter. And in case of that midpoint cycloconverter, we need one center tape transformer and four number of semiconductor switches. So in the upcoming slide, I will be explain these two type of cycloconverters. Okay. So this bridge type step up cycloconverter. So here this is the circuit diagram of bridge types step up cycloconverter. So this is the diagram, circuit diagram for bridge type step up cycloconverter. So in this there is two converter. One is this positive converter, the P converter, another one is the negative converter. So this converter has this positive converter has four thyristor. One is that P1, P2, P3 and P4, and again in the and negative converter also have four switches, that is N2, N1, N2, N3 and N4. Okay, and here there is one load is connected. So based on that load we'll get the output, and here this is the input voltage, and this is the positive side and this is the negative. This is positive and this is negative. So during positive half cycle, or we can say 0 to pi of input, that P1 and P2 will be in forward biased from the positive converters. This P1 and P2 will be forward biased from the positive converters, and this N1 and N2 will be forward biased from the negative converter. And during the negative half, means that pi to 2 pi of input, that P3, this P3 and P4 will be forward biased from the positive converter, and this N3 and N4 will be forward biased from the negative converter. So if we see the circuit, so I have separated these two circuit. So this is one and this is the second circuit. So if we see the circuit figure 1, this circuit 1, here we can see that how that what is the direction of the current flow. So if in the duration of positive half cycle, so this is we will considering this part, that 0 to pi or positive half cycle, the current will start flowing from this side, and it will go to this P1, again it go to the load, then P2 again get back to the negative. So here we are getting that positive output voltage. So here we are getting that positive output voltage, this output voltage is positive. And again if we see the this when this and in this at that time, that P1 and P2 will be in forward bias, that P1 and P2 from the positive converter. Now when this N1 and N2 will be in forward bias from the negative converter, um, in at the time of that 0 to pi or this positive half. So how the what will be the direction of the current flow? So here also that current will flow from here, then it will go to this N1 and go to the load, then N2, and again it get back to this negative. So here also whatever output voltage we are getting, that is this is the positive side and this is the negative side, and this is the direction of the current flow. So here we are getting that negative voltage. So here we are getting the negative voltage, and here we are getting the positive voltage. So this is the direction of the current flow when during the positive half cycle. Now we'll see during the negative half cycle what will be the direction of the current flow and what will be the output voltage. So again here I have separated these two circuits, then circuit 1 and circuit 2, for this duration, for that negative half or pi to 2 pi, means in this duration. So here what will happen, that P3 and P4 will be in forward bias. This P3 and P4 will be in forward bias. Now that current will start from this minus point, and it will go to that P3, then go to the load, and this positive. So here whatever voltage we are getting So that's why that is positive. So whatever voltage we are output voltage, that V0 is positive. Whatever output voltage we are getting when this P3 and P4 in forward bias, then output voltage is positive. Now if we consider this negative converter, where now this N4 and so N3 and N4 will be in forward bias. Now in this N3 and N4 will be in forward bias. Now in this condition, so that current will flow from this negative and it will go to that this N3, then load, then N4 and go back to the positive. So here this is the this side is positive and this side is negative. The current is entering from the here. So here we will getting that whatever voltage, output voltage, that is negative. Here we are getting that output voltage positive. So this is the when for this 0 to for pi to 2 pi, and for the pi to 2 pi duration, this is the output voltage, that is positive, and this is the direction of the current flow in case of that positive converter, and this output voltage is negative, and this is the direction of the current flow for when this N3 and N4 is in forward biased. Now we'll see the waveform, means how this step up, means how we are getting this, how we are stepping up the frequency by using this cycloconverter. Means this is the time period, and we know that Fn is equal to 1 by T. So here we have divided this time period into that small t1, t2, t3, t4, t5, t6, t7, t8, t8 like this. Now in this time period we'll trigger, this is the input waveform and this is the output waveform. So based on our requirement, we can the sequence of the switches, means we can turn on and turn off the switches. So here the input signal, that is the V input, this is the input voltage, and this is the output. So what is the frequency for this input signal and output signal? So here Fn is equal to 1 by T, that input frequency of this input voltage is 1 by T. Now here we can see if I take trigger, if I make the sequence like this, then what will be the output frequency for T1? Suppose this is T1. For this time period, this P1 and P2 will be on from the positive converter. Again from T1 to T2, this N1 and N2 will be on from the negative converter. Again T2 to T3, that T2 to T3, this is T0, okay, T1, T2, T3, T4, T5, T6, T7, T8. So these are the time periods. So here from T0 to T1, this P1 and P2 will be on from the positive converter. Then T1 to T2, this N1 and N2 will be on from the negative converter. Again T2 to T3, this P1 and P2 will be on from the positive converter. Again T3 to T4, this N1 and N2 will be on from the negative converter. Now after that, this from T3 to T4, this P3 and P4 will be on from the positive converter, and then T4 to T5, this N3 and N4 will be on from the negative converter. Then T5 to T6, this P3 and P4 will be on. Again T6 to T7 to T8, this N3 and N4 will be on from the negative converter. Now we will see how we will get the what will be the output waveform if we make this sequence, this type of sequence of these switches. So for this time period, it's if P1 and P2 will be on. In the previous slide you already checked that. So when this P1 and P2 will be in forward bias, in that case whatever output voltage we are getting, that is positive, that V output voltage is positive. When this sequence, this N1 and N2 sequence will be on, so in that case whatever output voltage we are getting, that is negative. So again here also when P3 and P4 is on, so at that time whatever output voltage we are getting, that is positive. And when N3 and N4 is on, so at that time whatever output voltage we are getting, that is negative. So based on this we need to draw the output waveform. So here P1 and P2, at the time of P1 and P2, that voltage, whatever voltage we will getting, that is positive. So that's why, so this up to this will be on, after that again it will be off. So here from P1 to T2, this N1 and N2 will be on. So and according to that previous circuit, so when this N1 and N2 is on, so at that time whatever voltage we are getting, that is negative. so this voltage. So again after that this sequence will be on that P1 and P2, so at that time we will get that positive voltage. Similarly that for like as previous one, this N1 and N2, at that time this is we will get the negative voltage, so this is the negative voltage. Now again after that P3 and P4 is on from the positive converter and we will get the positive voltage, and after that this N3 and N4 will be on, so at that time we will get that negative voltage. Then for this P3 and P4 that positive, and this N3 and N4 negative. So this is the output waveform of when we'll make this type of sequence. So here we'll calculate the frequency. So here total time period is T. Now this time period is T is equal to T by 4. T by 4. So for this time period we need to calculate the frequency, whether we are getting that output frequency it is higher from that input frequency. So F out will be 1 by T by 4. So that F out will be 1 by T by 4 because T is equal to T by 4. So so from this what we'll get, this F out is 4 F in, means whatever output frequency, that whatever voltage we are getting in the output, that frequency is 4 times of that input frequency. So means this by using this cycloconverter, by using this sequence, we are getting that output frequency is higher from that input frequency. Now here there is another circuit, second circuit, where we are getting similar circuit is there, but here is let sequence is little bit different, means we have increased that time period. So in here this is the T1 T0, then P1 is T2 T3 and T4. So means up to this two, this P1 and P2 will be on, and up to this N1 and N2 will be on. Again up to this P3 and P4 will be on, and up to this N3 and N4 will be on. So if we make this type of sequence, then what will be the output frequency? So here so these are from the positive converter, so whatever output we will get, that is the positive. And again for these are from the negative converter, so whatever output voltage we will be getting, that is the negative voltage. So this is the waveform, and again we are considering that P3 and P4, so output voltage is positive, and again we are considering that N3 and N4, so that output voltage is negative. Now we need to calculate that frequency for this output voltage. So here the T is equal to T by 2. In the previous case T is equal to T by 4. Now F out will be 1 by T by 2. So means that is 2F in. 2F in means 2 into input frequency, means whatever output frequency we are getting, so that is double of that input frequency, means in the output whatever frequency we are getting, that is more than that input frequency. So this is also a step up cycloconverter. So here we are getting that frequency double, and here we are getting that frequency is 4 times than input frequency. So this is a bridge type converter. So according to our requirements we can make the sequence and we will get the output.